Welcome to this low latency loopbacks feature spotlight for the Apollo MxFE. Applications requiring the capture and retransmit of RF signals are common in aerospace and defense. The control of delay time is critical to emulate movement. In some cases, signal manipulation and injection are needed. Apollo MxFE has 4 internal loopback paths. Depending on the path, the user can choose options such as buffer memory or BMEM. There are 3 functional blocks of BMEM in the receiver data path. To add precise delay, set the number of delay samples. The step size of the respective block depends on the sample rate at the block. To change signal frequency, utilize the coarse and fine NCOs. Set the frequency and the phase offset. Fast frequency hopping can be used to hop the NCO in the quickest time possible. Finally, blend the looped back data with transmit JESD data by using signal blending. For loopback 0, 1, and 2, latency is deterministic and the received data path is not interrupted, so ADC data still flows to JESD. The loopbacks provide lower latency than the traditional approach of implementing in the FPGA. Let's take a closer look starting with loopback 0. It is the path with the least latency. The data out from the ADC FIFO is looped back to the transmitter DAC FIFO. The ADC DAC data rates must match to use this feature. The HSD and BMEM block is available to add delay. The step size is 1 over the sample rate. At 20 gig, it's 50 picoseconds. And the maximum programmable value is 65,535 samples. The BMEM blocks can be configured to hop between 4 programmable delay settings. The switching happens on a selectable event, either trigger or GPIO. For more information, see the example loopback 0 BMEM delay hop in the API. Observe loopback 0 data path latency timing with no BMEM delay, and then total delay with the max BMEM setting. The time is dependent on device configuration. Next in the data path, loopback 1 routes data out of the coarse digital down converter, or CDDC, into the coarse digital up converter, or CDUC. Each instance of CDDC will route to the corresponding CDUC. There is no crossing instances. The data rates at the CDDC and CDUC must match to use this feature. When the fine DDC DUC is not bypassed, blending is supported with 1, 0.5, and 0.25 scaling options for the loopback data. Blending is the weighted summation of looped back data with transmitter JESD data. The CDDC BMEM blocks are available to add delay. The step size is 1 over the sample rate divided by the coarse decimation. For 20 gig and coarse decimation set to 4x, this is 200 picoseconds. The max programmable value is 4,095 samples. Observe loopback 1 data path latency timing with no BMEM delay, and then total delay with the max BMEM setting. Next, loopback 2 routes data from the fine digital down converter, or FDDC, to the fine digital up converter, or FDUC. Each instance of FDDC will route to the corresponding FDUC. There is no crossing instances. The data rates at the FDDC and FDUC must match to use the feature. Blending is supported with 1, 0.5, and 0.25x scaling options for the looped back data. The FDDC BMEM blocks are available to add delay. The step size is 1 over the sample rate divided by the coarse and fine decimation. For 20 gig, coarse and fine set to 4x, this is 800 picoseconds. The max programmable value is 255 samples. Observe loopback 2 data path latency timing with no BMEM delay, and then total delay with the max BMEM setting. The loopbacks can utilize the available BMEM blocks in the received data path. Observe a max time delay example with loopback 2, where all BMEM blocks are set to the max value. This time is data path configuration dependent. Finally, we look at loopback 3, a JESD digital loopback which routes sample data from the JESD 204B or C JRX transport layer to the input of the JTX transport layer. It is after the FSRC and CFARE blocks, which must be disabled. The ADC DAC data rates need to match to use the feature. The loopback mode is only supported for link 0, and the only sample data is looped back. Utilize this loopback as a debug tool for the JESD interface, another option alongside running a JRX iScan sweep. Please reference the user guide for more details on using Loopback 3. Demonstrate the various loopback path examples using Loopback 0, Loopback 0 BMEM delay hop, Loopback 1-2, and JESD loopback examples in the API. More details in the device user guide. Request download via our product page on analog.com/AD9084. Thank you for watching Low Latency Loopback Spotlight for the Apollo MxFE. Please visit our page for more information.